So, today I will discuss about the basic analysis in the laboratory. So, when you will go to laboratory for doing some experiment, so we need to be familiar with some tools and apparatus that I have discussed. Now, you are going to do experiment. So, there is a setup of the experimental setup. Now, what you want to measure, basically when we are telling that we are going to do experiment, means you have aimed to find out some parameter. It may be verification of Ohm's law, it may be this to find out the Young modulus of a rectangular bar, okay, or of a material in form of rectangular bar, right. So, it may be this find out the density of water, find out the density of a material. So, whatever. So, we are going to do experiment, and in that experiment only we will not measure only one parameter. You may need to measure few parameters. Those parameters basically is related with the parameter which you want to report, what you want to measure. As for example, as I told this Young modulus. So, Young modulus that is related with the length of the bar, thickness of the bar, okay, width of the bar, okay. So, then it depends on the deflection of the bar when you are putting weight on the bar. Okay. So, that means when you are going to measure Young modulus depends on variables, few parameters, and you have to measure each parameter, and then you can calculate Young modulus using those parameters, right. So, today I will discuss that now you are going to do experiment. Now, how to start the experiment, that okay. So, first thing, so you have to take data. So, there are you see many experiments, many parameters involves, and you will measure them and collect the data. So, now how to collect the data, what is the procedure of collection of the data. So, there are some I will discuss, there are some important facts when you are going to do experiment. So, this I am telling this basic analysis. Okay. So, this first thing is that this data collection. So, I will discuss in general. Okay. So, how to collect data and where you have to be very careful, where you can do some mistake. So, this type of discussion will do in this case. Second, after collecting data, in most of the cases generally we need to plot data. So, we use graph paper. Nowadays, you can plot in computer. Okay. There are many software, but in software also whatever manually you are doing, so the same thing is done writing program. Okay. So, that is basically software someone has done for you, and you will use this software to plot data, but manually you should know how to plot it. You use computer software, you have to use, there is no problem, but you should know what is the in which way you should plot data. So, manually if you know, so that you can implement, you can apply in computer also, okay, because there are some important facts that I will discuss. And then other important things is that calibration. So, when you are going to lab and measuring something, so you may not get directly that parameter, okay. You can get that parameter in terms of some other parameter, but these two parameters have relation. So, how they are related, okay. They are related linearly, or they are non-linear, they have non-linear relation. So, you have to basically do calibration. As for example, if you want to vary the magnetic field, and with magnetic field some parameters, say resistance of a material, okay. So, how resistance varies with magnetic field. So, what you will do? So, you will put the material in magnetic field. So, magnetic field means there is a electromagnet which can, this magnetic field you can vary. So, in electromagnet between two pole pieces you will put the sample. Now, electrical connections you have taken, right, IV measurement mainly you have to do at different magnetic field. So, now you are varying magnetic field in electromagnet. How you are varying? Basically, you are changing current in the coil, okay, and then due to this change of current, magnetic field between pole pieces will change, right. So, in your meter, okay, there basically you are changing current, and that current, how much current you are changing, that you can see, that reading you can take. Okay. But actually your sample is seeing the magnetic field, okay. It will not see the current, and that is what I need also. So, at different magnetic field I want to measure the resistance, I want to measure the yes, resistance. So, it is basically by IV measurement you have to do. So, you are taking reading, or you are varying the current, and that reading you can get this from meter, okay. But your sample is seeing the magnetic field. So, now basically this magnetic field is coming due to the change of current. Now, this magnetic field and current, they have relation. So, for 1 ampere current, what is the magnetic field? For 2 ampere current, what is the magnetic field? For 3 ampere current, what is the magnetic field, right. So, when you are doing experiment, you are not getting reading of the magnetic field directly, right. You are getting reading directly, that is the current. So, now that is you need calibration, it is I versus H, okay. So, that calibration you have to do first. So, then you know this for this current what will be the magnetic field. Then I can, from current reading itself, I can convert to the magnetic field, right. So, for calibration you have to use some another instrument which will measure the magnetic field between the pole pieces. So, that is the basically Hall probe kind of thing. So, I will put this probe near the sample position, okay. So, this time I do not need sample, just I will take out sample, I will put the probe there, Now, I will vary the current, and then this probe, this is called Gauss meter. So, it will give me a reading of magnetic field. So, I will vary the current, and that is my variable, and result I am getting the magnetic field, that reading. So, this I versus A is that reading I will take. Okay. And plotting the graph, I can find out the average is called basically average. I think if it is linear, that is fine. If it is linear, then fine. So, you will get plot this linear curve. So, from their curve basically this you will find out the gradient. So, that gradient will be the basically calibration factor. Okay. So, this is the calibration, and another example I can give you this, say this you are going to measure temperature, okay, using thermocouple. So, when you are using thermocouple, so actually you are measuring the voltage. Okay. So, when temperature is changed, then voltage is changed, that signal basically you measure, your meter will give this change of voltage due to the change of temperature. Now, change of voltage and the change of temperature, they have relation. So, I am getting actually this voltage, not temperature, but temperature have relation with this voltage. Now, I have to scale it, I have to calibrate it, means this for change of 10 degree temperature, what is the change of the voltage, right. So, I have to take few readings, and then I have to plot it and find out if linear, so fine, if non-linear also region wise, or you have to fit with some polynomial and find out this constant say temperature T equal to say A of A v plus B v square. So, this kind of polynomial fits this data, and from this fitting you will get this constant value A and B. If you know the A and B for that thermocouple, so now for any voltage, okay, you can calculate the temperature. So, that is the calibration, temperature versus voltage. Okay. So, this very important this factor in the laboratory, this calibration of the instrument, and then error analysis. Okay. So, whenever you will do measurement, okay, you are measuring some parameter using some instruments. Okay. So, you have to your measurement cannot be very perfect. Okay. So, there will be error, and this error, this systematic error, random error, etc. There are lot of analysis, but I will not discuss in details, but whatever the main error comes in laboratory, and we calculate, we tell this percentage error in our measurement. Okay. So, see in simple way I will discuss that one. So, if you importance of this error analysis is that you will know this what are the sources of error, then you will be careful in measurement of this of the parameters, okay, to minimize the error. You cannot nullify the error, but you can minimize the error. So, how we can minimize the error? So, that I will discuss here. Okay. So, let me tell you about the data collection procedure. So, when you are going to lab, you have to basically collect data, right. So, if I let me discuss this data collection procedure. Data collection procedure. Okay. So, first thing is that I have told you, and many times I will tell you, because we will demonstrate many experiments, and I will repeat these things because these things are important. Case to case there are some variation, but today I will discuss in general whatever the experiment you will going to perform. So, you have to take care of this whatever I am discussing now. Okay. So, one thing is that, first thing is that repeat the measurement and take average. Repeat the measurement, and take average. So, that example already I have discussed. Okay. So, what is the importance of repetition of the measurement? Okay. So, that already I think I have mentioned. So, let me repeat it. So, it is in general it is not for particular measurement. So, suppose you are going to measure a length of a rectangular bar or a diameter of a wire. Okay. So, the same example I am taking, that is whatever I discussed earlier. So, basically when you are going to measure a length, measure a length of a rectangular bar, right, rectangular bar, or and okay, diameter, you are going to measure a diameter of a wire. Okay. This is just one example. Okay. So, there you should repeat the measurement and take the average, means when you are going to measure the diameter of a wire or length of rectangular bar. So, rectangular bar means this, it is this kind of rectangular bar we are taking, say okay, rectangular bar. So, you are going to measure the length. So, just you take meter scale or slide calipers or screw gauge depending on the length, but here I think length is say higher. So, you take meter scale. Okay. So, then you are measuring the length. So, just take one end of the scale here and another scale this other end. So, we have to see this end where it is, in which reading it is it will meet. Okay. So, that I will take the reading, right. Now, so say this is 7.3 centimeter, right. So, measurement once would be sufficient, but logic is of repetition of the measurement, that you see you have taken on this edge, on this surface measurement, you should check the other surface, that it may not be perfectly this two face, okay. This two face may not be perfectly parallel. Okay. If it is perfectly parallel, so then measuring once is sufficient, but it may not be the case in reality. So, there may be slight change of this length on different face. Okay. So, that you have to take care reality in reality. So, that is the you see this theory is one and that when you are going to do the experiment. So, that is basically different from this theory concept in the sense that this in theory this whatever parameter we are taking, that is we are considering this the accurate parameter. Okay. We will put accurate parameter, but in case of measurement it is when I will tell rectangular bar. So, it is the in theory it is the perfect. Okay. It is so, but in reality when someone have fabricated that rectangular bar, right. So, when fabricating this rectangular bar, so it may not be that perfect. Perfection is not 100% perfection. So, there may be some difference from the ideal case. So, considering this reality, you have to measure, you have to minimize this whatever the imperfection is there in fabrication of the rectangular bar. So, that how we can minimize, just repeating the measurement. So, that is why we tell this, just take the measurement along the edge. There are 4 edge. Okay. This is one edge, this is another edge, this is third edge, and here this another fourth edge is there. Okay. So, along the 4 edge just you measure and take the average. If any imperfection in the fabrication of this rectangle, that you are taking care, because this is because any imperfection that is going to affect your result. So, this imperfection, so to minimize this error in measurement. Okay. So, that we are repeating the measurement and taking average. So, that this we can minimize this error due to the imperfection of this bar. Okay. So, then you are taking reading of this along the different edge. So, say 7.2, 7.3. So, this is 7.1. Okay. You are getting. So, then you are taking average and fine, and this I have discussed when I discussed this significant digit. Okay. So, so that context was different, but here context is why we need to repeat the measurement and take the average. Okay. Similarly, this diameter of a wire, I think, yeah. Okay. When you are going to measure diameter of the wire. So, this you see wire, when we tell wire. So, in ideal case wire, it has uniform cross section along the length, right. So, that is the ideal case, and in theory we consider that one. Okay. But when you are going to do experiment, so in theory what you are considering exactly, I may not fulfill this one, but I should take action in such a way. So, I can go towards that requirement. Okay. So, that towards that ideal case. So, here we assume that. Okay. So, someone again is fabricated this wire, right. So, they tried to make it uniform cross section, but it may not the case in reality. So, considering that one, only I can minimize this this defect, okay, or I can minimize the error in my measurement, just repeating the measurement, taking the average. So, I assume that it may not be perfectly uniform all along the length. So, I will take few reading. So, I will take at this near this edge, I will take near the other edge, okay, and I will take, say, depending on the length, I will take in between these 2 more result, okay, or 1 result or 3 result depending on the length of the wire. And then, so using some, I think in this case you will use screw gauge. Okay. So, again I will take 3, 4, 5 reading depending on length. So, it is not fixed that repeat 3 times, repeat 4 times, repeat 2 times. So, you have to decide. Okay. So, there should be logic behind it. So, if length are higher, so I should take at more points. Okay. So, and here in case of this, so there are 4 edges. Okay, it is distributed this 4 edge. So, if I take along 4 times, so that is a good average. Okay. So, you will repeat the measurement 2 times or 3 times or 5 times, that you have to decide. There should be logic behind it. Okay. It is not fixed that for all measurement just take 3 reading, 3 times reading and then average. So, that is why in most cases students are doing. Okay. So, but this is not the way, just you have to take decision, and that decision, behind this decision there should be logic. Here why I am taking 4 in case of bar. So, that logic I told you. In case of wire, why I am taking 3 times or 4 times or 5 times, that is depending on the length of the wire. So, that also, although you are measuring diameter, but fact depends on the length of the wire. Okay. So, so that way this is the importance of the repetition of the measurement and taking the average. Okay. Then another example also I can tell you, say measure the time period of a pendulum. Okay. So, time period of a pendulum. So, second example I can tell you the measure a time period of a pendulum. Right, measure a time period of a pendulum, and in this case this pendulum is basically just one mass bob. Okay. So, it is hanged with thread. Now, just it is oscillating. Okay. If you disturb once, then it will oscillate. Okay. It will oscillate. Okay. So, time period is the time required to complete one oscillation, starting from here going other side and coming back, that is the time period, right. So, I want to measure the time period of this pendulum. So, now, so you can say that just once, just I will start this one, and just I will use my watch. So, starting from here it is going to the other end and then coming back. So, what is the time, just directly I will measure. Okay. But we tell no, you repeat the measurement. In this case repetition is slightly different. So, we tell that, so you are not directly measuring the time period. Repetition, it meaning maybe that, okay, I have measured time for one oscillation, what is the time, that I noted down. This is the first reading. Second reading, again I am taking another reading, again I am taking another reading, again I am taking another reading. Okay. So, this can be the repetition of the measurement, but in this case if we follow other way, means since this when it is oscillating, its amplitude will decrease with time, you know this, because there is a slight damping, air damping. So, but time period, its amplitude will change, reduce, but time period remains constant. Okay. This is the fact. So, what we can do? I can take, I will start my watch when it is here, from here it starts to go other side. Okay. then I will count number of oscillation, complete oscillation 3, 4, 5, 10, 15, 20. Okay. So, for 20 complete oscillation, what is the time? I will stop the watch and I will find out the time. Okay. So, now my average time period is what? This time I total time divide by 20. Okay. So, that will give you time period. Okay. So, this way actually we are repeating the measurement. Okay. Instead of individual measurement, repetition of this measurement T1 plus T2 plus T3, these are all time period. Okay. Now, taking average. So, that way we are not doing, we are doing this way. So, another, and again these things you can repeat, this is say T1, then another repetition you can do. So, this T1, another repetition you can do, again 20 oscillation you have taken, 20 oscillation you have taken. So, this is the T2. Okay. So, then 2-3 times you can do and then take average of T1 plus T2 divided by 2. Okay. So, here you see this way just one oscillation I am measuring, because this why this is better, that you have to know. It is better because for this case you are measuring short time, you are using your watch and measuring time, it is a very short time. Say it is 5 second. Okay. This oscillation, this time period is 5 second or 10 second even. Okay. So, if it is 10 second, so now error from where it will come? Error will be starting this synchronizing with this starting and the stopping or completing one oscillation. So, starting and stopping, so it should perfectly synchronize with your oscillation, and this synchronize. So, that is the so there will be error in this starting and stopping, and this error will come over this time to 10 second. If you measure this way, if you measure this way, this starting and stopping the watch, that error will come over this T1, small T1, okay, the time for this 20 oscillation. So, difference between this and that here your the starting and stopping, that synchronizing that error, that will be over this T1, which is more or less 20 times higher than this capital T1. Okay. So, same error will be distributed over this higher time, whereas in this case it will be distributed with its lower time, okay, which is 20 times less than the other one. So, in which way we will measure, this way or that way? So, obviously that way we will measure, and why this is better than that one, that you have to understand. Okay. So, again this not only repetition of the measurement, how to repeat, that also important, that I try to tell from this example. Okay. So, next one is basically this, when you are measuring parameter. Okay. So, you have to choose appropriate steps of variable x variable and note down the measure, actually reading you are noting down of y variable. So, second important thing is that choose appropriate steps of x variable and note down y variable. Okay. Okay. So, what does it mean? Why it is important that say Ohm's law, example take Ohm's law, okay. Verification Ohm's law. So, that is nothing but that is V equal to R I. Okay. So, that relation you have to verify, or say you have to measure this constant. Okay. So, Ohm's law basically V is proportional to I or I is proportional to V. So, then V equal to R I. So, this is the proportionality constant. So, it is like a y equal to C x, you know, this relation is y equal to C x. So, C is constant, x is variable, independent variable, and y is dependent variable, right. So, in this case, in this example, that y is basically V and x is basically I, right, and then this proportion, this constant C is basically R, right. So, for this measurement, so you have circuit that okay, there is a resistance and then you have put ammeter right here, and then you have voltage divider basically. You have to vary the voltage. Okay. Okay. So, this is a battery, okay, and so this voltage drop across this one. Now, from here I am taking voltage. So, that is the, so this I will connect here, this I will connect here, and this I will connect with some jockey ball, it is called jockey. So, you can vary the position on this. So, total voltage of the whatever voltage here. So, this total voltage is this one, okay, drop voltage drop across this one. So, this basically whatever the current will flow through it, and then whatever the resistance. So, that is the. Now, if you divide this resistance in different parts, means you are varying this one. So, this voltage drop across this portion. So, that will be the voltage across this resistance. Okay. So, and now you are noting down basically you have added voltmeter here. So, in this circuit what is the current? Okay. That current you are varying this voltage. You see this volt and this volt is not same, it is different. Okay. So, let me here write voltage of battery V V, voltage of battery, it is the equivalent. Now, here you are measuring for different current, you are measuring different what is the voltage dropped across this resistance. Okay. So, basically so you are noting down, your so what is the current, and then for this current what is the voltage drop across this resistance, that you are noting down. Okay. So, here what I choose appropriate step of x variable means here in which step you will change. Continuously you are not changing the current and noting down the voltage. So, generally we change it step by step. So, whether I will choose, so some 0 voltage, 0 current initially, and for that obviously it will be 0 voltage, should be. Okay. And then now next step, whether you will choose this variation in milliampere or or ampere or microampere etcetera. Okay. If say choose any unit say ampere. Okay. So, now next step you will change this 0.5 ampere, then 0, then 1.0, then 1.5, then 2.0. So, that way generally will vary, and the step I have taken 0.5 ampere step. Okay. So, I am increasing this I value in step of 0.5, and that throughout this measurement I have maintained that step. Okay. So, that's the way generally we do. We do not bother about the V, what will be the value of V, but we generally take equal step in x variable, and we note down corresponding voltage say 1 volt, this 2 volt, 3 volt, 4 volt, this we note down whatever the reading, because I do not have control over it, I have control over it. So, I am varying this one and noting down this one. Okay. So, this is the way we do, but this is appropriate for the case where y and x they have linear relation, Okay. Okay. In case of nonlinear relation, this is not good way to choose the step. Like here in this case linear relation means y equal to C x. Okay. There this relation is linear relation. Okay. For nonlinear relation, so if say y equal to C x square, okay, x cube, or C x square plus V x plus d. Okay. So, this x and y, this relation is nonlinear relation. So, in case of nonlinear relation, this way, so you have to be very careful to choose the step. That is why I want to mean choose appropriate step of x variable and note down y variable. Okay. So, I will continue in next class this nonlinear relation when these two parameters are related not linearly, it is a nonlinear relation, then how to choose the step very important for taking data. So, I will continue in next class. Thank you very much.